force ended up equal to gravity, to Fg, right?
Mm-hmm. Can you hear me, Professor?
I can hear you. Just a second. I'm almost finalizing here. Just a second. Just a second. Just a second. Oh, that's the wrong one. File. Preferences. Okay. Okay, good evening, everyone. I have Justin, Tree, Elizabeth, and Amanda. This is being taped. It's a pleasure to have you guys, and that's it. So I'm going over now questions. If you have specific questions, I would like to address some follow up. If not, I'm gonna start hitting you guys with free body diagrams. And Amanda, I think Amanda was the one who asked me something, wasn't it?
Oh, yes, I was just testing my microphone.
Oh, okay. Yeah, I can hear you.
Okay.
Yeah. And I have Anfan, very good. So all of you except Elizabeth and me have microphone mute microphone. Okay. Tree's there. When's the next exam? I'm not thinking about exam yet. I think we have scheduled next week, if I'm not mistaken, but it's not gonna happen. The next exam will be the one that will be focusing on Newton's law and energy altogether. So I haven't started energy yet, although Elizabeth has already studied everything about energy, potential energy, and gravitational energy, but I'm not there yet. Okay.
So during the test, will you give us all these formulas?
Yes.
Okay, good.
Yes, but I'm not gonna give you free body diagram with examples. So if an example is given in the exam, you should be able to, put your forces and do your projection in X and Y, establish your positive direction. Sum of forces along the axis you've chosen is equal ma, that's Newton's law, and go from there.
So would you give us, like, for example, would you tell us like gravity equals Fg equals mg, or would you not even put
No, those little things you should know, like gravity is equal mg. You should know that. G is 9.8. I can give you that. It's not a big deal, but the tension has no expression for it. Something you should know. The kinetic friction has an expression for it. I might give it. I might put it there in the equation.
Okay.
So, but how to project and decompose things, yeah, this is something you should know.
So I have another question. I'm gonna show that. So this little thing right here.
Yeah.
So if you put something like B right here, and you told us, obviously, you're not gonna tell us what direction it's going, like the projection. If we just wrote whatever's in the box as an answer, would we get it correct?
I give partial credit, of course, depending on the type of problem. If the problem asks for a final solution, like given the conditions given, what is the acceleration of that box? So then the problem requires a specific number. So, but if you do all the development and then you run out of time. I mean, I give partial credit, and you all know that.
Yeah.
Yeah.
So
Sometimes even you get wrong answer because you did some bad calculation. And it's very common, especially dealing with angles, is very common to sometimes the students have radians in the calculator instead of degrees and get weird numbers. Um, I don't take points because it's not physics. It's pretty much some silliness in calculators and mathematics.
But to
Although
start it,
mathematics is the language of physics.
to start it, we would always want to do exactly what's in that little box right there first, right?
That's how you do. Yes, you start. You start. Let me give you an example. Can you stop sharing for now?
Sure.
Yeah.
Okay.
Let me see if I can. Okay, so now wait a minute. Where is this? Right here. Share the screen and this one. Can you see this um, white page?
Yeah.
Okay. So annotate. So let's say you have a box. That's the simplest one, right? And I say, okay, this box has a mass of 2 kilograms. And the coefficient of kinetic friction between the block and the floor is 0.4. And I want you to do two things. One, indicate FBD. B, what is the acceleration? Right?
Okay.
So so it's two different things. So to find the free body diagram, then you go to the list of forces we studied before. But I'm not going to give you the list. You should know that. You should know, and there is no cheat sheet here. So you know there are tensions, you know there are normal forces, you know there is a weight. The weight is the gravity. This is the force that has an expression for it, mg.
Yeah.
mg. M is the mass, and in this type of problem here, this example, the mass is given. Other forces are what? Well, sometimes in this case, it is true. Sorry, we have friction. We have friction, and where's my pencil? My pencil is gone. Oh, there you go. Weird. I cannot get my pencil back. What happened with my pencil? Oh, there you go. No.
Try pressing the arrow key first and then switch to the pencil, maybe.
Arrow key? I did. Arrow key.
The arrow picture, the blue one.
The blue one.
Oh, over there on the up
mouse.
top, right there. Up.
Oh, you are
Right
a
there.
genius. Thank you. Okay, mouse. Now I lost it again. Now I'm taking mouse and I don't have my. Oh, there you go. Annotate. Okay. So, oops. Annotate. 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 So, and also the static friction, right? And static friction, you should know it's not an equation like kinetic. Kinetic is always an equation, the coefficient of kinetic friction times your normal force, right? Static can be that if you are getting close to break the motion, to break the still state, like we did in the lab. but can be 0, could be 1, could be up to that maximum value. So static friction is kind of a tricky. What are other forces? There is also spring force. We haven't studied yet, but we will. So for now, don't worry about it. But those are the forces. So if I ask for a free body diagram, you should be able to come over here and indicate them with a arrow. Now, the tail of your vector should be resting on the object, in the case, the block. So what are the forces? Well, I do have the weight, all is pointing in the vertical direction, equal to mg. I do have the reaction of the surface to the block, which is a normal force. And now you have to decide. There is an acceleration. I forgot to give you some more information. Let's say there is an external force of 10 newtons that is pulling this block to the right. Otherwise, you can't calculate. Okay. Since there is friction between the block and the surface, then you have to indicate with a vector. So you have your friction. Since there is motion, this friction is kinetic. Okay. Those 28. So then what you do next is, okay, what are, we want to calculate, these are the forces. So I have a pulling force that is given, the problem is given that. I have normal force that I have to be able to pull out of my good brain. The weight is there because my problem has a mass, and I have friction. So those are the 4 forces acting. Like Elizabeth, in your drawing, you have a little pig pulling this thing, right?
Yeah.
Yeah, like that. That's it. Any question with the free body diagram in this type of example?
Yes, I have a question.
Yeah, Tree, go.
So for the coefficient, will you always give us that coefficient?
In this problem, I'm giving the coefficient, yes.
But what if you don't have the coefficient? How will you find it?
If you don't have the coefficient, the problem might ask you to calculate it, but then the problem might give you information that will allow you to calculate that coefficient.
Can you help us? Can you help us find that after this problem to find the an example to find the coefficient?
In this case, it's not an information to be found because it's given. It's right here.
Okay, yeah, I understand. Like this one doesn't have it, but then can you like do a problem?
Yeah. I can do the next one. Yes, I can do the next one.
Thank you.
So, so everybody is okay with free body diagram here?
Yeah.
Okay, let's find acceleration now. So if the block is not going up and down, then in the y direction, here's my Cartesian coordinate system. So I choose one that is go and coincide with the direction of motion. So the blocks hypothetically is moving to the right because it's being pulled by Mr. Piggy, right? Mm-hmm. And so since it goes to the right, the book recommends, and I'm suggesting, set one of the axes, in my case the x-axis, coinciding with that direction of motion like this. So here's my x-axis. Therefore, my y-axis is up here. Okay. So sum of all projection of these 4 forces in y is equal to 0 because the acceleration in y is equal to 0. Newton's second law of motion is sum of forces is equal ma. Sum of forces in one direction is equal ma, or mass times acceleration, in that direction. So if we are looking at the y direction, there is no motion in that direction. So the block is always resting on the floor. So it's not jumping up and down like a popcorn. Therefore, acceleration is 0. So from here,
and that's because the forces cancel each other out, right?
that's exactly. The two forces cancel out, and there is not a net along that direction.
Okay.
So when you add up, or when you write down the projection, you have a normal force positive because it's pointing along the positive direction, and you have a mg that is pointing along the negative direction, is pointing down. That's why it goes with the negative sign. This is equal 0. So therefore, the normal force equals mg. Are we all good?
That's interesting. Okay.
Yes.
Okay. So the next step is, okay, I'm done with my y direction. How about my x direction? So the x direction is a tricky one because it's the direction where the motion goes. So you have an acceleration. Along that direction, and we are supposed to calculate that. Okay. So we do the same thing. We do Newton's second law, sum of forces along the x direction is equal mass times the acceleration along that direction, which is a. And that's what we want to calculate. So as we did before for the y-axis, we do now for the x-axis. Can I go down?
You need to switch back to the mouse. Click on the, yeah, there you go.
Click where? I click on the mouse.
Click on the hand.
The hand. What is the hand?
Right next
Oh,
to
the hand. Okay.
And I think you can. Okay, never mind. I think because you're drawing on it, it doesn't want you to move.
Yeah, I guess so. Okay, let me keep annotating. No problem. Oh, now I have a hand there. I want to annotate. Annotate. There you go. So what are the forces in the x-axis? I have a positive F. 10 newtons. That was a given information. And in the negative direction, I have a kinetic friction, Fk. And that is equal to mass times acceleration. So what I have written here is just Newton's second law in the x direction. So what I do next is, okay, F is given. Is 10 newtons. And what is the friction force? Well, the friction force, which is kinetic, has an expression for it. The expression is the coefficient of kinetic friction times the normal force. And I know the normal force is equal to mg. And the mass is given, and g we know. Therefore, our kinetic friction force is equal to a coefficient of kinetic friction, which was given, times 2 times 9.8. So this friction force is equal to, now we have to calculate. Let me get a calculator here. Do I have a calculator? No, I don't have a calculator. Where's my calculator? Where's my calculator? I have a calculator. No, where's my calculator?
I think it's 7.84.
Oh, thank you. Say it again.
I think it's 7.84.
7.8 newtons. So I'm plugging this over here. 7.8 is equal to mass 2 times acceleration. So let me go to, can I go to another page? What can I solve in this little hole right here? In this little hole right there. So 10 minus 7.8, it is 2.2. So 2.2 is equal 10 minus 7.8 is equal to A. And then when we divide both sides by 2, we find acceleration is 1.1 meters per square second. Problem is done.
Yay. So would you put something like this on the exam?
I might, but
Or
I
would
might
you make
not.
it would you make it more difficult?
I don't know. I'm full of tricks.
Wait, can you explain the last part again?
Yeah. Let me get out of here. So I go to mouse. See if I can move this. It's funny. I can't get my. I think I have to stop sharing this.
Okay.
I think I have to stop sharing this. Wait a second. And then yeah. And then I go back to here, right? What is there? There. Go there. Back to meeting. Share the screen. This one. Share the screen. Okay. So what do you want me to do?
That last part, that where the 10 newtons subtract the
Oh
kinetic
yes.
force?
So it had 10 newtons, I think.
Yes.
Minus 7.8, right?
Yes. Do they all have the same the unit measure?
Yes, because all of this is in Newton. Newton
Okay.
is the unit of force in Newton. This is equal to mass,
Which is 2.
which is 2. Yeah, that's correct. Oops. And go to mouse, annotate. 2. Oops. Annotate. 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 Come on, annotate. Two times A. Then 10 minus 7.8 is 2.2.
Yes.
Is equal to 2 times A.
And then you would divide it by the 2.
Divided by 2. And then 1.1 is equal A. And then the unit of acceleration is meter per square second.
Okay, so that I don't have to convert that 1.1 to anything else. It's just gonna be. Okay.
No.
See, that's what I was confused about.
No. Now, let's say you have a different problem. The problem is what is the coefficient of kinetic friction required to required to maintain a 3 kilograms block with an acceleration of why not 0.5 meters per square second as it is pulled by a force of let's say 10 newtons. 10 newtons. Okay? Does that make sense?
Yes.
So it's a problem. So what is the coefficient of kinetic friction required to maintain a 3 kilograms block with an acceleration of this much as it is pulled by a force of 10 newtons? Some straightforward problem like that. Oh, I don't know why I'm doing this.
Control Z. Control Z.
Control Z.
Yes. Oh, erase that.
Control Z. How do you know all of this?
Press it again or erase the mistake you just made.
What do I do next?
If you press Control Z, it go back to the last step that you.
Really? That's amazing. How you guys memorize all of that. So let's do a sketch of the problem. So you have your block. The free body diagram is the weight of the block. You have a reaction of the normal force on the block. It is pulled by a force of 10 newtons to the right. And friction always arises in the direction that opposes the motion. So those are the four forces. And when we go back and do the sum of forces in y, our conclusion will be, let's see if I can erase this. There you go. Come on. Where is my annotate? So our conclusion will, oh, dang it. Where is mouse? Comment. Oh, there you go. Annotate. Annotate. Our conclusion is that sum of forces in y is equal to 0 newtons. Therefore, normal force is equal to the gravity, which is mg. In this case, 3 times 9.8. So the normal force in this case will be 29.4 newtons. Okay?
Got it.
So now let's do the same application of Newton's second law of motion to the x-axis. So x-axis, positive direction to the right, y-axis we just
Professor,
did.
I have a question.
Yes.
So if Fn and Fg are always opposite and they cancel each other out, you're always going to make Fn equal Fg equal mass times g.
That's correct.
Okay.
If they are the way you said. I will give an example next. This is not the case.
Okay.
Okay. So in X, what we got is sum of forces in X is MA. Sum of forces in X is equal to 3 times acceleration. But what are the forces on X? I have a 10 newtons in the positive direction, and I have a kinetic friction also in the x-axis, but in the negative direction, and this is equal to 3a. But what is kinetic friction? Kinetic friction is equal to a coefficient, which is the quantity we are supposed to calculate, the coefficient of kinetic friction times the normal force. But the normal force, we calculated previously, 29.4. So this is equal to a coefficient times 29.4. Now I'm ready to take this quantity and plug in the previous equation. And there goes 10, and I will drop the unit so that I don't carry letters. So 10 newtons minus the coefficient times 29.4 is equal 3 times acceleration, and the acceleration is 0.5, is given. 3 times 0.5, which is 1.5. 3 times 0.5 is 1.5. So can I write? Oh, can you see me right here on the side?
Yes.
Oh, that's great. So let's use that space. So if I subtract both sides of the equation by 1.5, here's what I got. 10 minus 1.5 minus the coefficient times 29.4 is equal 1.5 minus 1.5. I subtract 1.5 from both sides of the equation, and I have a funny equal right here. Equal. Oops. Equal. Okay? So 1.5 minus 1.5 is 0. So then I can operate the left side of the equation. 10 minus 10.5 is 8.5. 8.5 minus 29.4 times the coefficient is equal 0. Now, if I sum both sides of the equation by 29.4 times the coefficient, so I'm trying to find the coefficient and operate this math equation, so I get myself like this. So what I did, I added 29.4 to both sides of the equation. So the side that had 0 now has 29.4 coefficient kinetic, because I added. And the left-hand side of the equation, this whole multiplication was canceled. And then I can find my coefficient when I divide both sides by 29.4. So I divide by 29.4. I divide by 29.4. So my coefficient shall be 8.5 divided by 29.4. So that's the problem you asked me to do. Is one that the coefficient is not given, but I give you enough conditions so that you can apply Newton's law and find that coefficient as one of your unknowns.
Got it. Wait, I have one fast question. It's just backtrack. Where did you get that 1.5 from?
Say it again?
Where did you get that 1.5 from? Like the 10?
Excuse me. The 1.5 over here,
Yes.
it comes as a result of multiplying 3
Okay.
times 0.5.
Okay. I see it. I see it.
Yeah. Now, are you ready for another one?
Yes.
Okay. So I'm going to do the same thing, except that now I'm going to place this block on a slope. Okay?
Got it.
You got it? Okay. So let me, I think I have to stop share. Can I do a new share? Let's see if I can. New share. Yeah, I think I have to get out of here, stop sharing. Then Acrobat Reader. Share screen. Go here. Share screen. Okay. Now, so let's go in this adventure. So here is the slope. And here is our block now is resting on a surface, and I'm gonna do exactly what I did before. Let me take this, do it again. So the block, oops, come on, rotate. Go to mouse, annotate. Shh, I'm gonna start cursing, I swear. Okay, oh God, hate that. Okay, so here's the block, right? I'm not gonna write the enunciate of the problem. It's the same as the first one. I have a piggy that is pulling the block to the right with a force that make more dramatic, 30 newtons. Okay, 30 newtons. The coefficient of kinetic friction is given, 0.1. And I want to find, or the mass of the block is equal 1 kilogram. And I want to find acceleration. Wasn't that a problem? Like the number one?
Yes, it's the first example you gave to us.
And I'm gonna give you the angle there, 30 degrees. So coefficient is given, the mass is given, the acceleration is not given. You have to calculate. So how do we solve this problem? So the first thing we do is what we did in the first problem.
Free body diagram.
Free body diagram, please. That's the first thing you do. So let's do it in an expanded way. Free body diagram. I have a lateral force given, 30 newtons. Gravity force always vertical, down, mg. Normal force perpendicular to the slope. Now, if the motion is to the right, here's the acceleration. Acceleration is not part of the free body diagram, but I like to indicate, to remind me, there is an acceleration along my x-axis right here. This is my x-axis, okay? Here's my y-axis right there. So it reminds me of that. Now, since friction is given, I also do have a friction somewhere here. Mm-hmm. That's the friction, okay? So those are the forces. So see the difference? The difference is an incline. The second thing you should note is that your normal force is not aligned with the gravity force. You see that?
Yeah.
Now, what aligns with the normal force now? Well, what aligns is not mg, but if this angle is 30 degrees, the 30 degrees appears right here, 30 degrees. So what aligns with the normal force is not mg, but its projection in y, which is negative mg cosine of 30.
And why is that other angle 32?
This angle is 30 because if you look at this triangle right here, this angle is 90 degrees. This angle over here, therefore, is 60 degrees, right? Because the internal angle sum of angles in a triangle is 180. So this is 90 degrees, this is 30, 120. So necessarily this angle is 60 degrees. But since this whole angle is 90 degrees, this one over here is 90 degrees, and since this angle is 60 degrees, therefore this is 30 degrees.
Okay.
So when you have the incline, after you've done this few times, you are going to write the angle that is given here in your incline. You're going to take this value and you're going to plug it right here without thinking too much, because you're going to get used to it. Okay.
What if it's going decline?
A decline?
Yes. Will it be the same thing?
Oh, it's the same thing. If the block goes up or down, it doesn't matter. The angle is the same.
Okay, got it.
Yeah. So, but see, the gravity is not the one matching up the normal force, but is mg cosine 30.
And it's negative mg because of the y-axis is going
That
down.
is good observation. That's why. So you have a positive orientation going in the direction I'm indicating. So the negative one is down. That's why you got a negative one.
Mm-hmm.
By the same token, if you look at the x direction, if I'm calling this positive, and I do, because I mean, by assumption, the block is moving to the right, up the incline, and so I'm calling this positive, meaning when you project the gravity in the x direction, oh God, Control Z, you said?
Yes.
Okay. Oh, it's not working.
It's not working?
Z. Control Z. Why keep doing that? It's my stylus. It keep something is up. See? I don't want that. Okay, wait a second. Eraser. Now let me bring the annotate again. Take the mouse. Where is the annotate? Mouse. I have to do something else. My tablet is not working fine. Why don't I go back?
There's a pencil on the other side. You see it?
Okay, I found it again. Okay, so you take mg projecting in x. The projection is along the same direction of friction, and now it's getting confused here. So basically, gravity, this is your negative mg cosine theta, and here is the negative mg sine theta, theta being this angle over here. So in the x direction, two things are going on. One is, and I'm going to write in blue, friction, kinetic. And the other thing also, I'm indicating blue just to, to help visualize this, is mg sine theta, or sine of 30. Now both of them go with a negative sign because of the orientation they have. So when you do Newton's second law of motion in the x direction, it goes positive 30 minus friction force, positive 30 minus friction force minus mg sine 30 is equal ma. So here you see in this expression Newton's second law of motion in the x direction. The only difference we have from this with respect to what we had before is the sign. So observe, if you go back to your notes, the equation, the form of the equation is the same except for this sine of 30. And this sine of 30 appears because now we are in a slope.
And how come you didn't use the angle 60?
I could, but I don't want to get some of you confused. I could write mg cosine of 60. I could do that.
Okay.
You stick with the sign. It's easier.
Yeah.
It's easier.
So I'm trying in the classroom and here I'm trying to do the same thing always, so
Okay.
you guys don't get confused.
Got it.
Okay. So here's the thing. What is my frictional force? The definition of frictional force is the coefficient of kinetic friction times what?
Time, mass.
No.
No, times the Fn.
Thank you. It's not times mg, it's times the normal force. Please do not forget that. This is very tricky. Why? Why trick? Well, because normal force in this case is not mg. Look at it. So
Okay.
if you look at your projection in the y direction, sum of forces in y equals 0. And then we have our normal force minus mg cosine 30 equals 0. So your normal force now is mg cosine 30. So which means your friction force is equal to the coefficient of kinetic friction times mg cosine 30. You got it?
Got it.
And now I could go on, but basically now is to plug numbers. So you have 30 minus friction force is the coefficient times 0.1 times m, which is 1, 1 times g times 9.8 times cosine of 30 minus 1 times 9.8 times sine of 30. Sorry, it's getting all crunching up. Is equal 1 times a. And then you can find your acceleration. Got it?
Like, plugging the numbers seem to be a little confusing, but I think I got it.
Yeah, the numbers, yeah, it's kind of a messy here, but what I did, I plugged numbers in this equation here.
And how did you plug those numbers in again from using the EFY and EFX? Is that right?
Oh, sum of forces in x and sum of forces in y? Yeah. This major equation here is sum of forces in x is equal m acceleration in x. So mass is 1 kilograms and acceleration in x I want to find. And the forces in x are the pulling force of the Mr. Piggy being retarded by the friction and pulling down by gravity, by the weight. And the more the slope is, the more this angle is, more the weight will force acceleration, will diminish the acceleration. Okay.
So you pretty much just add everything. So the thing that you circled, you just put everything on the x-axis, right? So that's why you
Correct.
put 30n minus F kinetic because it's negative, minus mg because it's negative cosine of 30.
Right.
Or sine of 30, sorry.
Or cosine of 60.
Yeah.
Yeah.
And then equal to mass times acceleration.
Right.
Because that's where the direction is going.
Right. And the book recommends, and I think it's a good idea, always place your x-axis along the direction of motion, right? So we did. And call the positive direction the direction in which your block goes. So like Tree mentioned, well, what if the block is going down? Well, if the block is going down, it means this force of 30 newtons wouldn't be enough, right? Like it wouldn't be enough to let me give an example like that. Let me stop share and share the screen again. So let's imagine almost the same situation, right? You have a slope and have an angle, 30 degrees. You got your block, and you have Mr. Skinny Pig now that can only give 5 newtons force in that direction, right? It's a constant pull of 5 newtons along that direction. The block has a weight of 10 kilograms. Okay? And in fact, let's increase. Let's put 20 kilograms. 20 kilograms. And that's it. And you want to know, I mean, what are the forces? Can you tell me what is the acceleration? Knowing that coefficient of kinetic is the same, let's put 0.2. Okay. So what's going to happen? In this case, you can see one interesting thing. 5 newtons is the force up the incline, right? Right?
Yes.
Yeah.
Right. So, but which other forces are in there? Well, I have the weight. The weight is 20 times 9.8 is this many newtons, right? 109.6 newtons, and normal force. And what else? Well, if there is friction, it means friction is acting somehow. But look at this. If this angle is 30 degrees, what is the value of gravity projecting x and y?
It's gonna be
Oh, he started again. Look at this. Why this happened, I don't know. Come on. I'm trying to get my pencil. You said there was a pencil in the side. Where did you see another pencil?
It's on the bottom, right next to the eraser.
Bottom next. Oh, I have a razor.
Right there.
Right there. That's
This
the
one?
pencil. Yes.
This is not a. This is not a. This is not a pencil.
It should be.
It's called Spotlight.
Oh.
Oh, okay. Annotate, 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 annotate. Yeah. Oops. Annotate. Okay. So what are the projections? So in Y is mg, so 196, negative 196 cosine of 30. This angle here is 30. But in x is going to be 196 sine of 30, right? Sine of 30 is half, so it's going to be 98 98 newtons that way. So can you all see what's happening?
Well, wait, where did you get that 98 Newton from?
I'll tell you. Let me go back to annotate. Where is my annotate? There you go. There you go. So okay. So how do I get this 98 newtons? So the weight itself is 196, right?
Yes.
So the weight, which is this force over here, this vector projected in x is equal to 196 sine of 30. 196 sine of 30. So sine of 30 is 0.5, is half. So 196 times half is 98. 98. So you have a force of 98 newtons pulling down this slope, and a skinny little puny force of 5 newtons pulling up. So what do you think is going to happen with this box?
It's going to be dragging downward.
So what's the direction of your friction force?
The pig.
Correct. So your friction force will switch, will be like that. So when you do your sum of forces in y like we did before, will be the same thing. Fn minus 196, which is the weight, cosine 30 is equal to 0. And then your normal force will be 196 cosine of 30. And then you calculate that, and it will give you some numbers of Newton. And when you do the same on x direction, now I will bring my x oriented downhill, because that's where the block goes. And it's easy for me, my brain works fine, and I think is recommended that you set your positive direction along the direction of motion, where the velocity is positive. So sum of forces in x is equal ma, and you want to find the acceleration. And the mass is 20 kilograms. 20 times acceleration. What are the forces in x? I have 196 sine of 30, which is 98. Positive, because it's along the positive direction, it's not uphill anymore, minus my friction force, kinetic, minus my 5 Newton. This is equal ma. So 98 minus frictional force is coefficient of kinetic friction times the normal force, 196 cosine of 30, minus 5 is equal to 20a. So what I do next is to operate this left-hand side using my calculator. So I take 98, subtract from this, and subtract from this. And then I get a number, and I divide every one by 20 and find my acceleration as being 98 minus 0.2 times 196 cosine of 30 minus 5 meters per square second. So I gave you the three, in fact, 2 or 3 basic, very basic examples of a box subjected to very common forces. So more complex problems start the same way. You have to identify which forces happen to be acting on your box, on your object, and then you have to specify your x and y axis, and then apply Newton's law to each one of these axes, MAX, MAY, and then resolve. Now I know in chapter 5 homework I placed several examples of these forces, and the lab this week I will keep you guys away from instruments, and we're gonna do a lot of free body diagrams. So I hope, at least for you guys, you got some momentum to get this information very well settled.
Is the homework for chapter 5 due on Wednesday still?
Wednesday this week. No. I'm extending to next week.
Thank you.
Yeah.
Thank you.
Yeah.
Is there any way that you can give do you have any more example that you can put on Moodle that we can actually try to do too?
I'll give a lot of examples for free body diagram in the lab. That's what we're gonna do in the lab. Free body diagram.
Got it.
Okay.
Do
So
you
this is
mind
important. If you guys are okay with this, you can operate your numbers, you can do your projections, you're good.
Okay.
Amanda, are you okay with this stuff?
Yes, I'm fine. Thank you.
Okay. I don't know who's still there.
Everybody's still on.
Everybody's still there? Okay. So do you guys have any question?
No, that's pretty good. I understand a lot better now.
Okay, very good. Very good. Okay, wonderful. All right, so don't miss class tomorrow, 7:45.
Okay.
Take a bunch of
Good
shot
night.
of coffee. Be there on time.
Okay,
Thank you.
thank you.
All right.
Thank you.
Thanks.
See you guys tomorrow.
See you tomorrow.